Good afternoon, everyone. From Paris, France, this is Stéphane Chenard. I'm a senior consultant with the satellite market research firm Euroconsult. And I am pleased to welcome you to the 7th of GVF's acclaimed webinars organized in association with Satellite Evolution magazine and supported by Kencast. Kencast makes equipment for on-the-move video content delivery. So if you're watching this from your private Learjet, maybe you're using their systems. You may also be using one of the new satellite antennas that we will be discussing today during our panel on grand segment transformational antennas. Will terminals realize the promised LEO connectivity revolution is the question in front of us. With us today are 5 panelists from around the satellite industry. Michele Franci, Chief Operating Officer of OneWeb. Before that, Michele had managed the delivery of some of the largest satellite programs of Inmarsat and SES, so he knows a few things about multi-billion-dollar projects. And I know many of our attendees will hope, Michele, that you can tell us the latest about that one in particular. Next, we have Brian Billman, Vice President of Product Development for Isotropic Systems. Bill Milroy, Chairman and Chief Technology Officer of Fincom. Bill co-founded Fincom in 2000 after coming from one of the main electronic antenna houses, Raytheon. Ralph Brooker, owner of SatProf, who needs no introduction to the GVF crowd because his organization conducts the VSAT installer and technical training that is one of GVF's major activities. And Tony Russell, President of Antenna and RF Solutions for Kratos, the company formerly known as ASC Signal. Gentlemen, good afternoon once again, and thank you for joining us. Now we can see you all. Allow me to set the scene for our attendees who may not have been as immersed into this topic as you have been. Many billions of dollars are being spent on non-geostationary satellite constellations such as OneWeb, who's with us today, and Starlink, also in construction, and potentially several more. This is supposed to be the future of this industry, but for this new user antennas are needed, and that's why we're here, because these non-geo satellites move across the sky, and their users will constantly be switching from one satellite to the next. And so their antennas will need to track the satellites. And like most satellite dishes today, they'll have to move all the time. To keep it simple, this means parabolic antennas with pointing mechanisms, with gears, belts, and lubricants, or flat panel antennas with electronic steering. Of course, flat panel antennas have existed for many years and are used on airplanes, but they're still expensive, and they're not really available in large quantities. Parabolics with steering mechanisms also exist and are used on ships and airplanes, but these precision gears also make them expensive and tricky. And so for over 5 years, the vision has been that flat panel antennas and maybe steerable parabolics could become cheap enough to open the non-geo constellations to the big consumer markets, where many billions of consumer spending are expected to await them and help everybody close the books. That's been the vision. As I said, the industry still looks to be quite some way from there, and we'll try to see how far away and whether there is a problem there or not. Before we get there, Michele, allow me to start with you, since OneWeb has been front page news as it met this remarkably quick turnaround from Chapter 11 on March 27. You now have new owners, the UK government, of all people, and Bharti Airtel and Hughes, and hundreds of millions of dollars, up to $850 million, if I read the reorganization plan correctly, subject to the court's final okay that's expected later this year. OneWeb has been expected to become one of the largest sources of demand for antennas, such as we're discussing today, so it's extremely material to our discussion. Can you, for our audience, describe how the company now plans to return to business? Will the new OneWeb do generally the same things as the old OneWeb was planning, or are you going after new ideas?
Yes, thank you, Stefan, and hello, everyone connected here. Pleasure to be here with you, and to actually, I think it's the first time we are saying something public about the new OneWeb. So
yeah, we are very excited by that. Thank you for being with us.
Also, indeed, I think we went through a remarkably quick turnaround. And not that I am a great have a great experience of Chapter 11s, but I think one is enough to go through. It's kind of been a difficult and enlightening journey in a lot of ways. But indeed, we seem to be getting out. As you pointed out, we have a plan. Now, obviously, we're subject to the closing procedures, regulatory approvals, etc. So it will still take a little bit of time, but everybody's pretty confident that that things will work out relatively quickly. Our new owners, Barty and the UK government, and Hughes, that sort of confirmed their presence. They're the one surviving shareholder of the previous round. Are all very motivated, very engaged. I'm actually surprised by how engaged these folks are. Not Hughes, whom I've been working with for some time, but Bart and the UK government are certainly incredibly engaged, which gives us good confidence that they do want to make it a success, and that they won't just be leaning back waiting for us to make things happen, but get very operationally present. So you asked the question if we wanted to be changing things, or if this was looking like the old OneWeb. I would say a bit sarcastically, I think we're going to do better than the old OneWeb. So the objective is definitely not to go through another restructuring in some time, but to come out successfully and relatively quickly into service. Now, jokes apart, the general guidelines of our business plan have not changed. I think you all know that OneWeb, and that was before my time, but that OneWeb had started off with a sort of consumer rural broadband type of market focus, where indeed, and we'll certainly get back to it, but the low cost antenna is particularly an issue. And then in the course of say early last year, the business plan sort of shifted into more enterprise fixed and mobility markets. So we are keeping this mix of products and market verticals that we want to serve. The presence of Barty clearly puts an additional accent on the rural broadband type of application, because that's something they know very well and they're very keen to bring satellite broadband into. So probably we'll see a re-equilibrium, if you want, a rebalancing. So we went from completely rural consumer broadband to 100% or 90% enterprise. Now I think we're sort of going to end up somewhere in the middle, but roughly speaking, the same objectives. And in terms of timeline and where we're going to get to, I think again, subject to closing times, but we are pretty ambitious, and Barty and the UK government are very ambitious, and we are hopeful. We're certainly targeting to start initial service as early as latter part of next year. As you know, the OneWeb constellation is polar, and so we'll restart launching soon, and as we get launches.
So as a milestone, for instance, what does soon mean?
On the launching?
Yeah.
Well, hopefully this year already. We're looking at having at least 1 or 2 launches still this year. That again, depending on the closing, but assuming we get back into service somewhere in early Q4, we should be able to put 1 or 2 launches under our belt. And so with another 3 or 4, we'll be able to have decent coverage, so continuous coverage, if you want, over the northern latitudes, and that's where we are going to target starting service for fixed application, fixed sites in the second part of the year, and then following in somewhere in 22 with the mobility applications on various markets, and then finally with the aero solution. So I would say the business plan as it was, the difference in the initial plan, we were sort of looking at start of service all around early 21. Early 21. that was it. So if you want comparable things, we'll end up losing something between 6 and 9 months, which indeed going through a restructuring is not such a bad thing. And I have to say, I can't really say thanks to the COVID, because no one wants to be thankful to a pandemic like we're living through, but somehow our world has been slowing down all around us a little bit. So in a way, we are a bit a victim of the COVID, the way our restructuring happened and the Chapter 11 filing came about. But at the same time, it wasn't the worst time in the world to have to slow down, because the world around us has slowed down a little bit as well.
Okay, we could. I'll let our audience follow up with any questions they would like to put to you, and I'm pretty sure there will be a few. Let's move on. Let's move back a little bit to our main topic. So, cheap tracking antennas. Does anyone know how to make them? You have to unmute your microphones to jump at the question. Tony, Brian, Bill, you make antennas.
Yes, sir.
Can you how to realize the vision?
Well, I think it comes to the question of do people know how to make them? Yeah, most certainly they do. Phased array antennas and actively steered antennas have been around literally for decades. But of course, they've occupied very high-end applications. So particularly in defense applications, like the ballistic early warning system, or perhaps even the Spy-1 radar on the Aegis ship.
Tony,
so they're all.
That's exactly the point. Does anyone know how to make those things for $500 and how to deliver containers of thousands of them?
Yeah, so when you get down those, so the technology's there and the understanding is there, but for the full-blown consumer terminal, the cost seems to still be a long way off. So when you look at full ESAs, people like SatixFy and the University of Waterloo with CCOM have created excellent pieces of technology. Very impressive, and they're there, they work. But of course, they're 2 to 3 orders of magnitude higher than the sort of entry costs that they need to be, I think, for sort of mass market consumer terminals. So I think there's still a long way to the ultimate promise of them. But of course, there's lots of advances like hybrids. So Bill's going to talk, and ThinCom, of course, has done very well with their antennas. Very, very impressive pieces of work, especially in the airborne applications. But again, there's still a long way from being a consumer terminal.
Okay, Bill. So Tony says you're a long way. Well, we need to get there at some point. The industry needs to be able to deliver on the vision.
Sure. Although certainly we're best known for what we do on the aeronautical side. We are working and making some successes in the enterprise, and then even pushing to the consumer marketplace using our particular technology, as everyone else is. Speaking generically, I think there's some industrial examples that give us some hope. For example, if we look at a digital hard drive from a Seagate or a digital, those are you can buy those for a 1 terabyte drive for under $100. And if you think about it, it's pretty amazing the ability to do that with a controller, the platters, the kind of precision that needs to go in there. One might then argue that the SSD drives, which are a little bit more expensive and not quite as high capability, would be an example of a solid state example coming in. So those are all. It is possible to get down to those levels, albeit we're talking about quantities that are many hundreds of thousands. I think everyone's technology, our own plus those of our competitors, are generally scalable. In other words, we feel like we can work the market elasticities if they're there to work into the many hundreds of thousands of units. In our particular case, we're using injection molded plastics items like that to get the cost really down. I think later on we may discuss how low is good enough, and the differences between enterprise and I think even the consumer market is segmented. So if I could just say a word or two about it, and then I'll yield to the rest of the group. But on the consumer side, I think that's partitioned into two groups. I think one group is the cell phone, the iPhone kind of size. So that would be that maybe a $800 to $1,200 terminal would be acceptable. These would be in the United States as an example, in US dollars, and a subsidized model might work for that. However, other parts of the world, really $800 to $1,200 phones are not very common. We're really talking about more like a 3G phone. Even a $200 phone is somewhat expensive. And I think ultimately it may be very difficult to close business plans on an individual basis where each person who needs a $200 consumer terminal actually has one. My personal opinion is I think those markets will become more like a mini enterprise. There'll be someone in a village or in a small area who will have an enterprise terminal and resell their service on a wireless LAN to users for 2G, 3G, maybe 4G services. But the enterprise market, of course, I think is going to be the entry point. Aeronautical is one that we're interested in. Enterprise, cellular backhaul are the low-hanging fruit. And certainly I think everybody's on the dance floor in terms of meeting the cost targets for those type of systems. And we'll just have to see how far down the consumer cost volume space we can all go.
But today, the antennas that can track non-geo satellites, they're not at $800, they're not at $1,000, they are at tens of thousands of dollars, and they are available in small numbers. So are you implying that they could be made today if someone came to you with you or another manufacturer with a sufficiently large order, or are we running into the laws of physics? Can we make tracking gears out of plastic? Can those components be mass produced like they are today for cell phones?
I think the answer is yes. I mean, as I mentioned, there are some industrial examples of some very high precision. I use the digital drives, in terms of a digital hard drive as an example. So it can be done. I think in our industry, there's this discussion though of the chicken and egg situation where can we get the price down? And the answer would be yes in millions. Can we get to millions? Well, yes, if the price is down. So it's sort of a simultaneous equations that need
right. So the chicken has to come with its checkbook, and it hasn't done that. Brian, and Michele, because you buy this stuff. So you're in contact with those manufacturers and all others. You know what the industry can do, cannot do, is promising, is not promising, is delivering, is not delivering. Your perspective would be very useful as well. But Brian,
sure.
you're full and square in that business. So
yeah, sure. So I mean, as we've been kind of maturing our optical beamforming technology, we've of course evaluated it across a wide range of applicable markets, both within SATCOM and outside of SATCOM. So of course we've looked very closely at consumer broadband. And I think a lot of what Bill said is spot on. I completely agree with a lot of that. I think, we certainly have a path where we believe we can get down to those really low cost points. I believe the stepping stone there is probably more of that, community broadband where you're getting that low cost enterprise type terminal for a group of users instead of all the way jumping to that consumer broadband market. And honestly, I think Bill's also right about that chicken and the egg thing, right? Because as a pre-revenue company like we are, that's a big risk to take and put all our eggs in that one basket. And we're seeing, of course, people shift their focus, as we heard earlier, OneWeb kind of shifting away from their consumer model. So it wouldn't have been right to put all our eggs in that basket, right? So, I mean, I think in my mind, if anyone probably succeeds there, the most likely might be SpaceX, I think. They're, of course, vertically integrated. Maybe perhaps Amazon will get there. And I certainly hope they do, because that's going to help push our industry forward. But that's, while they're focusing on that, I think our focus is more on working with the experienced players to kind of offer game-changing features for their sophisticated and advanced customers, because that's something that we know we can deliver. We know we have features that nobody else has. And we also know that the demand is there right now, today.
Well, Brian, you can clearly, as a topic, you can have a good life selling high-end antennas for enterprise markets, which are what your existing customers are mainly focusing on, you don't have a multi-billion-dollar constellation to amortize.
That's correct.
Michele is in that spot. It can, if those cheap antennas are not there to unlock the consumer markets for you, then what?
Well, so I think a lot of what was said. First of all, I want to underscore as well. I think in a lot of ways the components, so the ability to build relatively cheap antennas or terminals, and I do want to underline the word relatively, because somehow, Bill was making a good point today. In a lot of parts of the world, people can spend $1,000 on a phone, and they consider that normal. But then when it comes to satcoms, we consider $1,000 expensive, or you hear that being said. So we have to pay attention on what we're targeting. Indeed, if we are going after the areas of the world that are today underserved and that don't have access to connectivity, and where cost is a real issue, there you do need, definitely you do need cheap solutions. But I would agree, probably the solution there is only going to be sort of community Wi-Fi or sort of cell simulated type of setups, or frankly speaking, governmental supported programs, because it's going to be very hard on a purely commercial basis to sort of have close a business case. I think the chicken and egg was referred to a couple of times, and I think that is true. Today we can produce, or we could try to produce, relatively low cost antennas in the the low $1,000s for sure, but the industry is not willing to start doing that unless there are significant orders for it, and the orders can't come until you have a clear customer path to customers. And so it is a chicken and egg problem, and that's where I think government type of or public programs are the only way to support this and to make it happen. I think it's a matter of prepping the pump in a way, and then we can all get there.
What do you expect your initial terminals to look like? If it looks like it's going to take 4 or 5 years for the cost curve to get where you want it to be, I'd say there's multiple parameters in the equation. It's what people are willing to pay for, how much subsidization may be on the table, and so on. Can you start with cheap parabolics? Does it look like there's better solutions there?
We are certainly, so yes, we are planning to start with parabolics, not so much, or not only for cost issues, but also because of the type of markets we're going to start with. Parabolics are a good solution, and a reliable and a cost-effective solution. We'll be introducing electronically steered antennas right after that, a few months after that. And today we have programs in place that we're restarting that allow us to get to the order of magnitude prices that we've been referring to.
Tony, I know you're going to jump at this one because you're the parabolic guy on the panel. And I see you have your finger on the microphone. But the parabolic antenna, the low end ones that you can buy from, that's KVH sales, for instance, for leisure vessels, those start at $3,000, if I recall correctly. What's expensive in those things? Is it the gears? Can you make those out of molded plastic so that they live long enough to be good enough at a price? Or and generally for the panel, what's expensive in what we're discussing here? Is it the components? Is it more the manufacturing? Do you have to build new factories to realize the vision? So Tony, cheap parabolics, how cheap?
Yeah, sure. So in the parabolic antennas, the key expensive parts are the things that drive the motion and the things that handle the RF. So, if you look at, say, a direct-to-home dish that you might have on the side of your house, it doesn't articulate or track, of course, but if you look at the actual parabolic surface, the main reflector, it's just a piece of stamped metal. So, that's relatively cheap. They're made in Mexico or whatever. The whole terminal is very affordable. But when it comes to some of the new LEO constellations, a lot of them are higher frequencies, and so the RF components themselves start to drive the cost. And that's particularly important for a true electronically steered array, because you're talking now about MMICs that may operate at Ku band or Ka band, and you're starting to, you're pushing the semiconductor technology, and so that becomes expensive. So, in some of the arrays we've seen, the true ESA arrays, the array itself, equivalent to, say, a 1 meter aperture, can cost today about $250,000. So it's very expensive. So I do think that parabolics will play a role, and I do think that the cost of a parabolic can be driven down. To use the analogy of, and it's a very crude analogy, the receive-only TV articulated antennas that people had on RVs and such like, literally motion driven by cords and very, very simple hinges to do the elevation. So, the bill of materials of one of those sort of antennas is measured in, the tens of dollars, not thousands of dollars. So I think there is a solution out there. It's not a solution for us because, as a manufacturer, we tend to do the high-end, high-capacity gateways. I mean, we did a lot for OneWeb, so we shipped over 160 antennas for OneWeb, but they're all very precise, very high-end, 3.5 meter sort of aperture. So it's a very, very large compared to a consumer terminal.
I think what has been on the grapevine in the early years of OneWeb, not anymore, I understand, but was precisely the mechanical parts of those antennas, because they had to track. The RF worked fine, but those things were on the beach, and they were getting salt and marine air, and they just corroded faster than expected. You're saying the cost is more in the electronics, which could be where the price, we know, can come down quite a bit with volume, than with the physical wear out of mechanical parts, which could be more tricky if new materials have to be and new manufacturing processes have to be invented. Am I capturing what you said?
Yeah, I think you need a completely different approach to do the user terminal. I mean, when I'm talking about the consumer, with the consumer, of course, probably outside the US, but say in South America, you're going to have the consumers that have a lot of churn. You can't amortize the equipment over a very long period of time. So it all kind of suggests that your user terminal is going to have to come down to maybe a couple of $100 or something like that. So that's going to be a completely different philosophy to the antennas that you use for your TT&C operations on your very expensive assets in space. So you're going to have this diversion of objectives. So I think it can be done, and it needs to be done, I think, to possibly even allow the LEO constellations to survive. If you look at OneWeb, you look at O3b, for example, we all know O3b stands for the other 3 billion. But of course, instead of their original vision of serving hitherto unserviced areas of the world, they had to change that vision because they couldn't put cheap user terminals on the ground. So they ended up looking at concentrated, aggregated groups of people who could afford the service. So like the cruise ships, for example. I think that's a great example where, you know, you may have on a large cruise ship today 3,000 plus connected devices. So it comes back to the local distributor model that others have talked about already today.
Right. Questions are starting to roll in from the audience, and we are reminded, we've been discussing the flat panel, very innovative technologies, and the parabolics a little bit like they are the same, like they are directly comparable, like they are the same thing. The gain of a flat panel antenna is actually today less than what you can get with a parabolic, which of course there's ways to deal with that, but today it's the common wisdom is that you cannot be as good with a flat panel as you are with a good old parabolic. So for Brian and Bill, and maybe Ralph as the impartial referee here, can the two technologies be converged in terms of performance, or the advantages of the flat panels will always have to be paid for with slightly less performance? Who wants to take that first? Ralph.
Yeah, let me just try to set the stage a little bit just from an ecumenical perspective, and being in the business of explaining things, let me try to clarify some things that have occurred to me. One is that there really are only two reasons that flat panel antennas are needed, considering that, as you say, parabolics are close to theoretical optimum in most ways, although you can do a little bit better in some aspects, as Bill pointed out to me the other day. But if you think of a parabolic antenna as essentially a big phased array antenna with an infinite number of elements and a super low loss feed system, it's space fed. It's sort of like the ideal way to make a zero loss antenna. And if you shape the illumination function, you can get almost any pattern you want. Its biggest problems are, number one, you can't quickly steer it, as obviously, and secondly, it's tall. So that's why you see the two demands for this class of flat antennas are really coming from two different drivers. One is aeronautics, where you need the low profile for streamlining, and you're not so bothered about performance and cost, but you have to have that low height. And the other is LEO constellations, where you need to not only track the satellite across the sky quickly, but you probably need to hop quickly from one satellite to another. And you have to do it fast enough to not interrupt the traffic, which is a little bit easier these days. Since
like I said at the beginning, and those antennas have to be in tough places because there's going to be so many of them.
Right.
So it's the state of the art equalizing between the two types of technologies.
Yeah. So the key question is, what does the constellation require the antenna to do? If the constellation is geostationary, then it's almost impossible for a flat panel antenna to compete, except in niche areas with the parabolic. But if the constellation does require that you have quick hopping and quick tracking, then that drives the specs of the antenna, and then it narrows down the specs too, especially for parameters like scan angle, elevation range, and that can make it possible to happen.
Okay.
Yep.
Brian and Bill, defend your technology. We just heard
Yes.
it's impossible to make them as good as parabolics.
Sure. Yeah, I'll jump in here and then hand it over to Bill. So it's interesting to use that wording because really what we're doing at isotropic is almost kind of meeting in the middle between flat panels and parabolics. So, you know, as you mentioned, flat panels are always fighting physics as you try to scan out towards the horizon. But, you know, kind of a secret is what we're doing actually isn't completely flat. The way transformational optics works is we're taking kind of a couple centimeters above what would be that flat aperture, and we're mathematically solving what we need to do within that predefined space to give us the performance and features we need. And so we'll take that trade all day because we're still a low profile antenna. It's still low profile enough to get onto those aero platforms, to get onto things like rail where height is an issue, but just those couple of centimeters is really giving us an enormous leap in performance and features. So things like having very flat gain all the way over scan and getting extreme scan angles beyond 70 degrees are something that are a lot easier for us to achieve with just that little bit of extra volume. But, you know, I also think the other half of that is that, you know, as we start to solve these issues across the various terminal manufacturers, I think we're going to see that conversation change to move beyond just gain and scan range for flat panels, because we're going to solve that. And so that's kind of where we're thinking at Isotropic. We've already proven out our performance over scan and our gain. So really what now we're thinking about is how can we change what the customers are ultimately doing? So one example of that is that we can have dynamic resource allocation within that terminal. So a lot of flat panel terminals can have an issue with very large power consumption. Well, we can dynamically at any point change the number of resources that are on a given beam basis. So we can boost your beam to maintain your SLA over scan or based on link characteristics, for example. We can change the performance based on prioritizing critical traffic. Or on the opposite side, we can actually scale back and use only the minimal amount of hardware to reduce your power consumption to maximize your life on, let's say, battery or solar power. So, you know, I understand why there's this focus on gain and scan, but I think, you know, we're solving that, and you're going to see that conversation move away from that pretty quickly.
So if I could just pipe in. So I think I share a lot of the philosophies with Brian. I think each of us has a different approach for achieving this. I think the need to work to very large scan angles, which is certainly that's a real need now in the aeronautical domain when you're flying polar routes with GEOs, and we find a lot of need to even go below 10-degree elevation angle in terms of closing links. Now, there is some argument, which may be a discussion point, would be that as LEOs come on board, then the need to go to the lower elevation angles becomes less important, and perhaps the G-on-Ts or the equivalent dish sizes become less. Our particular opinion, which maybe is self-serving, is that for at least in the interim and probably for a foreseeable future, you're going to need terminals that could do GEO and LEO, a hybrid approach. So meaning that you're going to want to have pretty big, big dishes is a relative term, but most of the requirements we see for the enterprise LEOs are in the 65 centimeter kind of range in terms of equivalent dish size. So depending on what technology you're talking about, that could be a very large flat panel array. And although many of the constellations, when they get up to tens of thousands, if they get to that point, satellites, there should be a lot of satellites near zenith that you can get to. But in the case of smaller constellations, a Telesat, an O3b or mPOWER, to a lesser degree in terms of OneWeb isn't planning to put tens of thousands of satellites up, then actually when you run the math on that, you actually have to work to pretty low elevation angles, particularly when the constellations are first launched. And in the case of those constellations that have inclined orbits, then of course you have the classic, if you're above a certain latitude, you're going to need to be able to work to very low elevation angles. So we don't think things are going to radically change. In other words, I don't think we're going to go from very from a 65 centimeter dish capable system that can go to low elevation angles. I don't think it's going to immediately move to a 12-inch dish that only has to scan within 45 degrees of zenith. That might be the direction that we move to, but I think it's going to be some years before we get that. So I think you need to bring the G-on-T, you need to bring the EIRPs in the near term, and you need to do that as economically as possible. Maybe that's obvious. And the trending, though, you want to have a technology that can move in the direction of being able to get to those lower price points and the smaller size. And I'd maybe refer to Ralph, who's in terms of looking at the, at the markets in general. But I think that's my opinion of where the trends are going.
And we have about 25 minutes to go. So at this point, let me thank Kencast again for making this possible today. We have quite a few questions coming in. Understandably, folks want to know how much things cost and what's the current, even if prices are going to come down, can we put some numbers on what the industry is delivering? Michele, let me ask you, since you're in contact with so many vendors and presumably you're getting quotes, so many antennas for so many dollars per unit. What's the market range that you're being offered today? Never mind where you want to go, but just as an indication of what the industry thinks it can deliver when it has that serious conversation with you, what are the sort of numbers that you are being offered today?
Also, first of all, the way the conversations go today is actually a little bit the other way around. I've witnessed a lot of conversations where we sort of come in with targets, and then people tell us what they'll be able to do, and then after a little bit of time, we see whether that becomes close to be feasible or not. But I would say in the realm of sort of fixed installation, flat panel antenna based terminals, we can today we can get into I would say the sort of order of magnitude $1,000 units all in with decent volumes. I think that's an absolutely achievable target. It's
$8,000 per unit for decent volumes.
For decent volumes, yeah.
Okay. How decent?
Well, decent doesn't mean millions either, right? It's you know, we're still talking about orders of magnitude of 100,000 or 150,000 or something like that per year. So not huge mass market yet, but I think we can get there with, I would say, technological solutions that are still, you know, relatively sort of proven or established, not sort of leaps of faith in terms of very, very advanced technology. So, and I think with that level of prices, there is a wide market range that can be touched, and you know, maybe with different types of solutions. It's not going to be a real consumer type of market everywhere in the world, but it will go very far in terms of the rural broadband needs and feed the market growth around it. Now, we've been talking all along about sort of the low end. I think somehow when we talk about flat panel antennas, we should not forget that will remain a number of specialty applications where the driver won't be the cost of the unit in itself, but it will be either the form factor or the performance of it. So you know, we should pay attention to the fact that our market is a mix of all of these things, and we're not just, all of us collectively, I think, we're not just going after the super cheap solution for the very low end market, but a mix with what Tony was referring to earlier when he was sort of.
No, and you're also selling, you're also offering a package. So one of your attendees, for instance, he's telling me that he would be willing to pay $3,000 for an antenna. So that's good news. If he gets bandwidths at $30 a month for 30 GB, which is sort of 4G pricing. Today's satellite capacity is way higher than that. I don't know how much you're willing to comment on what the bandwidth, whether the low cost of the bandwidths could make up for the relatively high price of the equipment.
Yeah, so I can't really comment on where we're going to go in prices. I mean, in terms of one way, what our packages will look like, because there are a lot of variables in it, and so it would be a bit complex to explain it quickly here. But I think right now, today, if we compare the consumer market, like the terrestrial consumer market, essentially in the consumer market today, the cost of the equipment is a negligible amount, right? People tend to choose a provider for a fixed solution based on the package itself, and then the equipment comes sort of as a byproduct. It's a little bit different in the mobility market still today, but somehow we're already as well in an area where it sort of gets embedded in a subscriber solution. So I think over time we will probably get exactly in the same place for Satcom, at least for the large usages, and the pure cost of the bandwidth will be coming down, just because there is today much more efficient systems that are being launched, be it the VHTS satellites or the broadband constellations. Only in my last 10 years of activity, I've seen the pure cost of the bandwidth going down 7-8 times, right? I mean, a factor 7-8 already. So, you know, a few years ago, we were talking about $2,000, $3,000, $4,000 as being a reference price for bandwidth per month. Today, we're in the few $100s already today. And with these new systems coming up, it will go under the $100 for sure pretty quickly.
Well, hidden behind the curtain and coming out from behind the curtain a little bit is a Starlink antenna, which you may have seen as there's more details coming, becoming available on this. Have you all checked out what's been published on those antennas, and what do you think of this? It's not quite a curveball that you would think, but we have at least 2 audience questions on this one. Ralph, maybe as again, you don't sell antennas. What do you think of what you've seen? And all the others, I'm interested in your thoughts.
I mean, I haven't seen the insides of it. I'm not sure anybody outside company has there.
No, but we've seen the outside, and
yeah, you can kind of tell what they're doing. It looks like they use a electromechanical system to pre-point it, at least. But the antenna itself is some kind of an array. It's flat. It's clearly not big enough to be a parabolic center-fed reflector. And that might be a pretty clever solution in that they can reduce the scan angle by pre-pointing to generally the area that they have the most concentration of satellites overhead, which may not necessarily be at the zenith. And then they perhaps use electronic switching to hop between, to track and to hop between the satellites.
Has anyone else looked at this with an industrialist's eye and found whether it's possible to make hundreds of thousands of those at low prices and high reliability?
Yeah, I think we look at that as being very interesting. I think Ralph's correct. I mean, it clearly has a mechanical steering element, but I wonder if isn't actually a passive printed array for the actual antenna, but then all the motion provided mechanically, because on the images you can see that there's clearly a slot that would give it approximately 90 degrees of elevation range. And there's also a line around the circumference which suggests that something could rotate as well. So you've got both degrees of motion potential. So I would suspect it's entirely a hybrid, and it is probably not an electronically steered antenna, but instead totally mechanically steered. But again, that's speculation, as Ralph says. Probably none of us have had the opportunity to see inside.
But there's a really key issue here, though, Stefan, that relating to the hopping. I think it's quite, as you were saying, that Tony, that it's quite possible to follow the satellites with a mechanical system. And maybe you can make that really cheap with mechanical systems like Bill was describing earlier. But the real rub is when you need to hop between to the next pass of satellite. And it's a kind of a deep question in my mind, because it may be these days, since we all use IP traffic, we can tolerate more of a gap. We could tolerate 100 milliseconds or more or less of stall, of buffering of IP traffic, and allow the antenna enough mechanical time to move to the next satellite. If that was true, that means you could use mechanical systems potentially, or quasi-mechanical systems like the FinCom, to hop quickly enough and not have to have duplicate antennas to have tandem antennas ping-ponging back and forth, and that would reduce the cost a lot. So
well, not having to move back and forth too much is why SpaceX is launching thousands, not hundreds of satellites, I think. But yes, they've said there's going to be interruptions in the service, so don't use this for gaming, which is very Elon Musk-y sort of comment. So there's many elements. Can they be manufactured at what price? How often are they going to break down? And the service levels and the user expectations and the environment in which they have to fit. We've touched. Yes.
Sorry, presumably though, in terms of hopping between satellites, I mean, certainly today, if my internet service at home only had outage 100 milliseconds every 20 minutes, I'd be delighted. But so I think Ralph's got a good point. But I guess you could, for someone who's more serious, I mean, looking at them, they're probably mass producible in good, affordable numbers. So presumably, a user could choose to have two if they wish. But then again, the other thing with the Starlink is, the optimization of the path by the sort of inter-satellite sort of links is clearly pointed at users that would value very small improvements in speed. So you'd have to think like electronic banking or gaming or something like that. As opposed to the general consumer, I would imagine. So in that case, those sort of institutional users would probably be able to afford a much more expensive and superior antenna system, I would guess.
Yeah, I think the SpaceX is going after the consumer through, and then it's all about manufacturing. It's all about marketing and manufacturing, and I think that's probably the question we don't know yet, because a great design is important for consumer goods, but what actually matters is whether they can be made in large enough numbers. Let's shift gears a little bit for our last 10 minutes. We've touched briefly on regulatory aspects. Antennas have all sorts of regulatory implications. In the case of our FPAs, I'm reminded here that the side lobes of an FPA are not the same as the side lobes of a parabolic, and so are there licensing implications? Michele, maybe you have to take that into account, given what your licenses in various countries say you can and cannot do. Maybe that puts constraints on the sort of terminals that you can consider. The other aspect, and it's really the elephant in the room in any GVF assembly, and if you don't mention 5G and spectrum reallocation, then you're not really at the GVF event. But we have been discussing K-band systems here. For much of the telecom industry, it's what they call millimeter waves, and they think it's the future of 5G. And they expect satellite antennas to kindly limit their power flux density so that they can do millimeter wave 5G networks. So can it be done? Can interference just be filtered out? Or is it one more constraint on moving to this next generation of antennas that we've been discussing? Who wants to take that up? Michele, I mentioned you, but
a few words about it. So
open to everyone.
What we see, particularly in aeronautical frames, but these same requirements apply to maritime and fixed user terminals, and particularly in the KA band, the 27.5 to 29.5 band, which is the band that's being used by satellite the good news is there's 2 gigahertz of KA band. The bad news is everybody knows about it. So that same bandwidth, which has been shared for some time by the likes of, I don't want to play any favorites here, but by the likes of a Viasat or Hughes here in the States, those are now being used by the NGSO players. So those are already being used by O3B. They'll be used by mPOWER. They're filed for Kuiper. And so a lot of the theoretical interference issues that were all theoretical at one point, because actually there's always been the anticipation of NGSOs in the GSO requirements, but everybody would always get a waiver because there were no NGSOs. But now all those are going to be retested, those requirements. And then I wanted to bring up another complication is in the 27.5 to 29.5 band, it's not just satellite people who want to use that band. That's being used for the terrestrial point-to-point. It's being referred to as the 5G millimeter wave. So that's putting extra constraints even on below horizon emissions from aircraft, from maritime platforms. I think some of the folks here also could probably attest to on the gateways. That's also putting restraints on the gateways. The gateway antennas that are pushing up the satellites need to make sure they're not interfering with nearby terrestrial users. And so I think it's going to be a mess. I always joke with attorneys on the FCC and ITU. It's a great time to be a regulatory attorney And I think there's going to be a lot of cases that are going to come in, a lot of petitions to deny. I think this is going to be a big issue that's been ignored for a while, but it's really going to come to the forefront as everybody is now colliding in these areas in terms of frequency.
So it's going to be a mess. I was hoping that you would tell us that there's technical solutions to take care of the problem, but now you're sending us to the lawyers.
Well, it's a self-serving, but yeah, I probably wouldn't
You're not a lawyer.
We had a good solution with FinCom. The parlance in the antenna would be that you want to keep the side lobes. So you want all the power in the main beam, and you'd like the side lobes. We've always been concerned with the near and side lobes because on GSOs, those would be where the closest adjacent satellites are. So we always had to be concerned about not hitting those with unintended emissions. But now with NGSOs, that's no longer just a near and side lobe. That's everywhere in the upper hemisphere. On NGSO, you have to point it to the north. You have to be still protecting the GSO plane south. So it's not like just 1 or 2 points. It's really could be thousands of areas where your side lobes count. So we think the only practical solution to that is to have a naturally low side lobe structure, which is what we try to achieve and are pretty successful in our particular products at FinCom.
Just to clarify a little bit, most of the LEO constellations are actually using KU band for the user link. So KU interference is a big question with geostationary. And on side lobes, you can do some amazing things with array antennas that you cannot do with parabolics. You can tune and control the fire out side lobes by synthesizing the illumination function in ways you just can't do with parabolics. So as Bill said, that you have that power that we just don't have. A main issue, though, that you cannot escape because of physics is the beam width. And that's something we have to really be aware of as the NGSOs go out. Small antennas, no matter how you make them, they always have wide beam width. So if the LEOs are coming too close to the GEOs in the sky, or the LEOs are coming too close to each other in the same constellation, or two constellations are crossing each other on the same band, if you're using small antennas, the smaller the antennas are, the more complex the coordination process is between them. So coordination not only between LEOs and GEOs, but between LEOs and other LEOs for dynamic interference avoidance is really going to be key to success.
Michele, you're in touch with a lot of regulators to get licenses. Usually one of the things you have to give them is a description of the antennas that your users are going to use. Is any of them saying, yeah, we'd love to license you, but with those antennas, cannot do because we have other users in the band because of millimeter 5G? Or is this, are you confident that that's not going to be a constraint on your
on the user terminal side specifically, I'm actually quite confident that this is not going to be a huge issue, and it's not the main ones that we are facing. I think some of the points that were raised are today the more relevant ones when we talk to regulators, which is indeed how these different constellations will live together, or how much we protect GEOs, or indeed how much we will allow or not, or be a nuisance to the 5G allocations. And Bill was making the point of the gateway antennas. I think that indeed is one of the biggest issues that comes up with regulators today, because that's actually going to be the biggest source of issues. And the more a constellation has gateways, the bigger the issue. So in that sense, OneWeb is not too bad. Obviously, GEOs are better, but we are doing away with not too big a number, but for constellations that are very low on the horizon, for instance, very low in altitude, the number of gateways is going to be important, and that actually is an issue that comes up very significantly with regulators. On the terminal side, indeed, we have masks to work with, and we're expected to stay within those masks. And I would say that the burden on proof is on us. And in general, I know my experience, terminal manufacturers know how to deal with these things. And if you want to, you can build terminals that respect regulatory constraints. It's not, you lose a little bit of performance, but you can definitely do that. And in that sense, indeed, flat panel antennas are are good for a number of reasons. For constellations, for sure, because indeed the look angle is higher, is not as constrained. So yeah, I think from the perspective of the subject of today, of the user terminal antennas, that's not the biggest challenge we have. But as we're pointing out, regulations in general are definitely a challenge for both constellations and new systems coming up because of the parallel 5G competition.
Yeah,
Right.
I'd like if I could just jump in for a second there. I'd like to reiterate, I think, a critical point that Ralph made earlier. So, of course, in terms of side lobes for the terminal itself, that's something that we focused on from the beginning, and that's why we built hardware both in KU and KA to bring it into the chamber and measure that and prove that out because it's not easy to simulate, so we had to prove that out through measurements. But the other side of that, in terms of that, dynamic interference mitigation throughout the network and across networks, I mean, that's something we're seeing. I think, some of the more keen operators are looking at 5G, as you mentioned, and seeing how they're implementing things like software-defined networks to really change the intelligent management of their service. And I think that capability becomes magnified once you have the flexible user terminal that can then jump between any different beam on that constellation. And then really, in my mind, the paradigm shifts happens when you can then dynamically switch between networks. Bill mentioned this earlier, going between LEO, MEO, and GEO. And once you start adding multiple simultaneous beams from a terminal, then the power, I think, really becomes incredible there, both in terms of interference perspective, but also in terms of just user experience perspective. So a couple examples of that would be on an aircraft where a single terminal can, let's say, connect to a LEO constellation to provide IFC, but also have a multicast through a GEO satellite. Or a frontline fighter can send mission critical data over 2 links at the same time to ensure it gets to where it needs to be. Service providers are able to reduce their costs, improve their SLAs. Of course, you're able to maximize your throughput through those 2 different links at the same time. So, really, I think the interoperability part and then that dynamic management is really the key moving forward. And so, it's about increasing the sophistication of how the customer is moving that traffic across the various networks.
Right. We really are in the last 5 minutes. We can still take one audience question that's not yet come in. Some of those questions are a little bit too personal or technically detailed, maybe to take on the air. But what you've mentioned is that it would be nice if those antennas could handle both the LEOs and the GEOs. And they should also be plug and play, by the way, because we don't want a bunch of bespoke systems that are fitted only to one system. They should be easy to install. Starlink says it is plug and play. We don't know if that how true that will be at scale, but Ralph, you deal with the installers. I'm wondering if they are ready to deal with hundreds of thousands of installations for constellations with those fairly new technologies.
I kind of think the concern about installation cost and having installers come is a little bit overrated. There have been experiments with doing self-installs, particularly direct-to-home television in the US. And it turned out that the cost of having somebody spend a few minutes pointing the dish was pretty small compared to the benefit of having someone who made sure that it worked and was a representative and brought the right gear and so forth. So I don't know, dish pointing is not that hard, really. That's not really the main issue. But getting, it would be nice, of course, if you could have self-installable antennas that consumers could just order off Amazon and it would come and you stick it on the roof. But they still have to know things that they don't want to really fuss with, like where are the trees and how do I get power up to the roof and well, how do I get the cable to run? Issues like that.
Mm-hmm. Which are best left to the homeowner, right?
Well, yes and no. I mean, many homeowners don't want to be climbing on their own roofs and pulling cables and wires. They just want to have some guy come and do it. I mean, look in the US and other countries, rarely do people install their own cable TV. The cable guy comes and hooks it up and puts the box in and he tells you when it's working and he leaves. It takes 20 minutes. That seems to be a pretty acceptable model.
Right. Yeah, I also know of one broadband provider who got out of the business because they were getting service calls from 6 or 7 time zones away. This was in Russia. and they didn't want to cross half of Russia just to take care of one complaining customer. And if you don't do that, then pretty quickly you're not a consumer business anymore. Tony.
But doesn't the fact that these new terminals are going to have to track, doesn't that, if anything, make it easier, because they should in some form or another be intelligent enough to lock onto something themselves? So so you won't have the consumer trying to point their direct to home dish sort of mechanically. They should be smart enough, shouldn't they?
Tell the consumer that they're not smart enough to do it. But I think in principle, yes, of course, great ideas. We've been trying to deal with the practicalities here of a market that is really still emerging, where we can't really pull an antenna out of the box yet and be sure that it works. Some of you mentioned that computers used to be at that stage, and that now you buy them like noodles, and you know what to expect when they get out of the box, and they still don't work quite like what you expect, actually. I think that's about all the time that we have today. We did receive somewhat more questions than we could take on the air, so we'll do our best to address those questions offline. Be aware, some of our attendees want detailed performance specs and hemispheric plots from you. So I hope this webcast will maybe result in some sales leads for you guys. And apart from that, I think we had an informative debate on where we stand today. Anyone wants to have a few closing words?
Well, I'd just like to say, as a parabolic guy, we see the development of electronically steerable phase arrays as actually being highly complementary to what we do. So we think that anything that helps build out the market for our customers is good for us. So we don't see them as competition. We see them as actually complementary. And so from that perspective, we're anxious to see success for everyone who's trying to do those sorts of antennas. Plus, also, we think
we love parabolics too, even if it scans on a string, as long as it addresses the market needs, that's what matters, right?
If a UFO on a stick can gain popularity, then anything's possible.
If I can make a comment, I think debates like this one are really good, and I think despite the slowness that sometimes we were all accused of, I think the market for the user terminals is really boiling right now, and there are a lot of interesting things happen. But more importantly, I would say, when it comes to satellite networks, connectivity networks, people tend to focus on the satellite and forget that what really makes or breaks a solution or a system, or makes it actually profitable, is very much on the ground. And so I'm glad that actually we're having these kind of conversations and putting so much focus on it, because it's indeed the core of the war, if you want. At the end, the success will be measured from the network characteristics, something we haven't talked about today, but sort of network management. Brian sort of hinted to it at a point in time, or the user premises equipment that we'll be able to deploy.
Indeed, it's not about launching satellites. It's well, true, we need to launch satellites as well. Not much happens, but to the broader telecom folks who may have been following this, the satellite terminal industry is very much on its toes and thinking only of the end user, and hopefully those manufacturing questions will be nailed. I'm glad we had this conversation. I trust it was useful to the 400 or 500 of our attendees from around the world. As a reminder, a recording will be available soon on the GVF website, so you can play it on a loop. And as I said, we'll also try to answer the unanswered questions. Please go to gvf.org to register for the next webinar that will be taking place at the same time in 2 weeks, August 27 at 3 p.m. UK time, 2 p.m. Universal time. on serving underserved communities, which is what we all have been trying to do in our ways today. And until then, thanks again to everyone and goodbye.